Hi, this is Dr. Anusudha. Today we will discuss how to solve differential equation using Laplace transform. So, why we are using Laplace transform? So, what is the purpose? So, we are using Laplace transform. So, I will discuss that one. Then we will solve one problem. Okay. So, we know very well we have to convert time domain signal to frequency domain signal using Laplace transform, right? So, what are the benefits? So, if you are converting time domain signal to frequency domain, we can easily analyze the signal with respect to phase and magnitude spectrum. So that's why we are converting time domain signal to frequency domain using Laplace transform. Especially for time domain, we are using the Laplace transform. For discrete time signal, that is n. For n, we will use Z transform in order to convert time domain to frequency domain. Today here we will discuss one of the problems, uh, how to solve differential equation using Laplace transform. Okay, so in our exam, usually these type of questions will ask from the examiners. Okay, so this is one of the differential equation. Okay, so if it is time domain, the mathematical equation is in the form of differential equation. If it is in discrete domain, right? If it is in discrete domain, it should be in the difference equation. I think you know very well that one. Okay, so these are the initial conditions. Okay, so they have given this is our input signal. So this is our initial conditions. Okay, so by using these conditions we have to solve this differential equation. Okay, so first, this is the second order differential equation. We have to take the given equation. Okay, so this is our given equation. For this given equation, we have to apply Laplace transform. Okay, LT means Laplace transform. Okay, so you know very well. So d square y of t divided by dt square means s square y of s, right? S square y of s. Okay. So thereafter, as they have given the initial conditions, we have to write. If they have not given these initial conditions, we no need to require to write this initial conditions. Actually, they have given, so we have to use that initial conditions in our differential equations. Okay, so here, so we are converting this differential equation to frequency domain using Laplace transform. For this one, so we have to write d square y of t divided by dt square. So for that one, we have to write these three terms. So for d square y of t divided by dt square means s square y of s minus s into y of 0 minus dy of 0 minus dt, right? So this is the first term is the given equation. The remaining terms are the initial conditions. Similarly, we have to write for 3 into dy of t divided by dt. For this one, 3 into for dy of t divided by dt. The Laplace transform for this dy of t divided by dt is 3 into s square bracket s into y of s minus y of 0 minus. So for this one, 2 into y of s. This one, s into x of s minus x of 0 minus. So once we have converted time domain to frequency domain using Laplace transform, we have to separate the constant terms and y of s terms separately, right? So this is our y of s terms. Okay, this is our constant terms 2s minus 1, minus 6, minus 6, minus 1 is a minus 7. I have taken these constant terms in the right hand side. So it becomes 2s plus 7 plus s divided by s plus 1. Okay. So thereafter, so here I have to find out y of t. That is my ultimate goal. So I have taken this s square plus 3s plus 2 in the right hand side. Okay. So it looks like this. Okay. So all these terms, I mean this y of s terms comes under here as a denominator term. Okay. So after modifying this equation, the final equation looks like this. Okay. Then um, so I have to take this one s square plus 3s plus 2, right? So for this one I have to find out roots for this second order polynomial equations. You know very well how to find out the roots, right? So for this equation s square plus 3s plus 2, so right, so these are the steps to find out the roots of the second order polynomial equation, right? So 3s s square plus 3s plus 2, isn't it? So for this one, it becomes 2s square. So if we are multiplying these two terms, so we will get 2s square. If I am adding these two terms, I will get 3s. So after that, so we have to consider these two terms and these two terms. So then we will get s plus 2, s plus 1. So then afterwards, after find outing that one, okay, so we have to before that so we have to take LCM these two terms. Okay, so we have to modify this equation. Okay, so if we are multiplying these two, 2s plus 7 into s plus 1, so right, we will get 2s square plus 9s plus 7, right? So that is here. Okay, so here I am retaining plus s, right? So you know very well how to take this one. S plus 1 is not here, so I am multiplying here s plus 1. Here I have all these two terms, so I am retaining this numerator term like as a s, right? So after multiplying this 9s plus s, it become 10s. Okay, so our final equation is this one, right? So here I have, by using this equation, I have to find out y of t. Okay, so before that I have to modify this equation. I have to find out ABC values by applying partial fractional technique, right? So as I said, we have to find out the roots of this equation. So this one is the roots. So I have this s plus 1 and s plus 1. This is the multiple roots. We call this one as s equal to minus 1, s is equal to minus 1. So I can multiply these two terms. The equation looks like this. For this equation, I have to apply partial fraction technique, right? So you know how to find out the uh, how to apply the partial fraction method for if you are getting multiple poles, right? So multiple poles, right? So you have to apply partial fraction techniques. Then you have to find out the values of a, b, c, right? So for the first we have to take this one, right? A divided by s plus 1 plus b divided by s plus 1 whole square. If it is cube means it becomes plus c s plus 1 whole cube, right? So but here I have only s square, so I will limit it here, right? So then c is divided by s plus 2, right? First easy to find out the value of b, right? So that's why I'm finding here the value of b, right? So s plus 1 whole square. So the I have to replace this y of s. B is equal to s plus 1 whole square into y of s. This is the equation I have written here, right? S plus 1, s plus 1 whole square cancelled out. So for s is equal to minus 1, I have to substitute for this equation. So we will get b is equal to minus 1. So in order to find out a, you know very well how to find out the value of a. 1 divided by, this one is a 2. What is the higher order of value here is, this is 2. It is, if it is 3 means the value is 3. 3 minus 1 is, it becomes 2. But here I have 2, right? So the value of n, right, here, or we can also call this one as L, right? So L minus 1, it becomes 2 minus 1 is equal to 1 factorial. So similarly here it becomes L minus 1 divided by d ds to the power of L minus 1. So here I have only 1, so it becomes divided by ds. So that these terms exactly it comes here. Okay, so for this one we have to take differential equation. Okay, so if you are taking, you know very well how to take differential equation, right? Du divided by dv, right? S plus 2 whole square, s plus 2, right? I have to take differential equation for this one. It becomes 2 into s square. S square means the differential equation of s square is 2s, right? It becomes 2 into 2, 4s. So here differential equation of s is 1. So it becomes 10. The differential equation of constant is 0. So here I have not written anything. So here similarly 2s square plus 10s plus 1. The I have to take differential equation for this one. S is 1, 2 becomes 0. So I have written here 1. So if we are solving this equation, we have to apply s is equal to minus 1, right? We will get a is equal to 7. So finally we have to find out c. So here the value of numerator c. So the value of denominator is s plus 2. So we have to take s plus 2 y of s, right? We have to write y of s equation here. S plus 2 get cancelled out, right? So here, so with the for we have to find out the value of c for the value of s is equal to minus 2. So if we are substituting value of s is equal to minus 2, we will get c is equal to minus 5. So whatever we have determined the value of a, b, c, we have to substitute this equation. So in order to find out y of t, so after substituting the equation, the final equation looks like this. So for this equation, we have to apply inverse Laplace transform in order to find out y of t, right? So you have to memorize the Laplace transform for the given function and inverse Laplace for the given function. Okay, whatever it is for any type of signals, please try to memorize the equation. Okay, then only we can easily apply in order to convert time domain to frequency domain. In order to convert frequency domain to time domain, we can easily apply the equations. So right, so y of s, if you are applying inverse Laplace, it becomes y of t. So 7 is the constant terms. We have to retain uh, retain that number here, right? So for this one, 1 into divided by 1 divided by s plus 1 for this one. So we have to write e to the power of minus 80 here. Instead of a, I have 1. So right, I have to write 7 into, this is a constant term, e to the power of minus t u of t. This is a Laplace transform of t, right? So 1 divided by s plus 1 whole square, it becomes t. For this one, s plus 1, I have to write a to the power of minus t u of t. So minus 5 is the constant term. So for you have to apply the Laplace from 1 divided by s plus 2. So e to the power of minus 2t u of t. So this is your final equation. You have determined the y of t equation from the differential equation, right? So usually you will get this one for 13 marks, or sometime they will ask for 7 marks also. Okay, thank you very much. I think you have uh, uh, you are able to understand this problem. Okay, thank you.